Section 3.2, product and quotient rules. Product and quotient rules. Why do we call it the product rule? Because if you have a function that is written as a product of two functions like that, then the question is, what is y prime? Well, people might come and say y prime equals, you find the derivative of the first function times the derivative of the second function. Is that correct? The answer is no, it's not. We can't do that. It doesn't work out. If you apply the definition of the derivative, it doesn't work out this way. So then what? Is there a rule for this? Yes, the rule says if y equals f of x times another function g of x, then the rule says y prime equals, watch how I'm going to write this. You copy it twice with a plus sign in the middle, not minus sign, plus sign. You put a derivative on the first one and derivative on the last one. This is called product rule. This is called product rule. And to apply this, let's look at an example. Find y prime if y equals x squared plus 3 times 3x minus 5. I'm going to show you this one as the first example, and then I'll give you more examples you can work on. Ready? What's y prime? You can copy this twice with a plus sign in the middle. And then we place a derivative on the first, derivative on the last. What's y prime? Derivative of this one is 2x plus 0 times 3x minus 5 plus, keep this the same, derivative of this one is 3 minus 0. Please don't leave it like this. Multiply it out, because later on in chapter 4 you must multiply it out. So y prime, get used to it from now, distribute 6x squared, 10x, 3x squared plus 9. So y prime would equal to 9x squared minus 10x plus 9. See how we used the previous section? Any questions about this? I'm going to write another one and you try this. Try it on your own. So this one, we do the same thing as we did the previous one, y prime. We put the derivative on the first one times the second, plus keep the first one the same times the derivative of the next one. So y prime equals, this one is 3x squared plus 1, and keep this the same. Keep this the same. To find the derivative of this one is 1 plus 0, 1. Then we need to distribute all of this. 3x cubed plus 24x squared plus x plus 8 plus x cubed plus x plus 4. Let's see what we get. 4x cubed plus 24x squared plus 2x plus 12. Any questions about the product rule? The next one is called the quotient rule. The quotient rule. If we have a function y equals f of x over g of x, what is y prime? Well, it's not going to be f prime of x over g prime of x. The quotient rule says y prime is f prime of x or g of x f prime of x minus g prime of x f of x over the denominator square. That's the quotient rule. You take the denominator times the derivative of the top minus the derivative of the bottom times the top. Find y prime if y equals 2x. Start with something very easy, over x plus 7. So to find y prime, after you tried this, so y prime would be, the formula said, you take the denominator times the numerator derivative minus the denominator derivative times the top over the denominator square. So y prime equals x plus 7 times the derivative of this is 2 minus derivative of x plus 7 is 1 plus 0 1, and keep this the same, and this is x plus 7 square. And what does that give us? Y prime equals 2x plus 14 minus 2x minus 1, and the denominator never get expanded, just keep it as is. Then as a next step, 2x cancel, we get 13 over x plus 7 square, and that would be the answer. Another example, if y equals x squared plus 1 over 3x plus 1. Try this for 2 minutes. We can go over it now. So y prime, again, denominator times the derivative of the top, derivative of this times the next one over the denominator square. This stays the same, denominator always squared. Y prime equals 6x squared plus 2x minus 3x squared minus 3 over 3x plus 1 squared. That gives us 3x squared plus 2x minus 3. Keep the denominator the same. Now I'm going to give miscellaneous problems or functions, and you're required to find their derivatives. Let's start with the first one. Find y prime for each of the following. Y equals a over x to the fourth. You don't have to use the product and quotient rule. You can use everything we learned so far about derivatives. Minus bx to the third minus cx plus d. And this is a function in x. This means anything beside x is considered constant. That's one of them. Y equals u squared minus the square root of u over u. That's another one. So for the first one, we need to do some rewriting. I see fractions here. I don't want to do a quotient rule. It's easier to rewrite it first. Nothing needs to be done here. Nothing needs to be done. Nothing needs to be done. Then y prime is negative 4 down, a x to the negative 5 minus 3bx squared minus c plus 0. Y prime negative 4a over x to the fifth minus 3bx squared minus c. Next one, the easiest way to do this, rewrite this as 1/2, is to bring this up as u to the negative 1 before we start finding the derivative for this. Then y equals u, 2 minus 1 is 1, 1/2 minus 1 is negative 1/2. Then it's ready to be differentiated. Y prime is 1 u, that's a 1, minus, bring the negative 1/2 down, becomes 1/2, negative 3/2. So y prime is 1 plus 1 over 2 to the u to the 3 halves. Next example, s of r equals 4 pi r squared. Find the derivative for this. Always no negative exponents in the final answers. And I'm going to write another one down. Find the equation of both the tangent and normal lines to the graph of y equals f of x, the square root of x over x plus 1 at x equals 4. Okay, for this one, don't be tricked with the variables. The variable now is not x, it's r. So r is the variable. It's like x squared. So if you want to write it as s of x, that would be 4 pi x squared. So pi is a constant, 4 is a constant. So when you want to find the derivative of this, you bring the 2 down, multiplied by the 4 pi. That makes it 8 pi. R 2 minus 1 is 1. So that's the derivative. 4 pi is a constant. That's why we didn't touch it. We didn't make any changes to it. Next one, find the equation of both the tangent and normal line. What is a tangent line? This is a tangent line. What is a normal line? The normal line is the line that is perpendicular to the tangent line at that point. So this is tangent. This is normal. Tangent line, normal line. Okay, so to find the equation of a tangent line, what do we need to do? Okay, the first thing we need to do is we need to use y minus y1 equals m times x minus x1. I have only the x value of the point, so this goes here. To find the y value, y1, you substitute that x equals 4 into the original function. And let's see what we get. We get 2 over 5. That's y1. So I found y1, x1 is given. The only thing left to find is m, the slope of the tangent line. Okay, we defined before that the slope of the tangent line is defined as the derivative of the function at the given point x1, which is 4. So it's going to be f prime at 4. But to find the value of f prime of 4, you need the derivative of the function. So we need to find f prime. So let me rewrite the given function back. You can write this as 1/2 over x plus 1. Then we need to find the derivative of this function. How do you find the derivative of this function? We use quotient rule. F prime of x is, we take the denominator times the derivative of the numerator minus derivative of the numerator times the denominator over denominator square. Don't substitute in until you find the derivative. This stays the same. Bring the 1/2 down, x to the negative 1/2. Derivative of this is 1, and x to the 1/2, keep it as is. Then what we do, we can multiply. That's the easiest way to do this. Multiply this by the first one by x to the 1/2, so that cleans up the negative 1/2, and we do the same thing for each one of them. Let's see what happened. The 1/2 stays as is, x plus 1 the same. These two, it's gone, becomes x to the 0 minus these two, x to the 1/2 and 1/2, it's x. And this is the square root of x, and this stays the same. If you substitute 4 in, that's okay to do it now. 1/2, 4 plus 1 minus 4 over the square root of 4 and 4 plus 1. 5/2 minus 4 over 2 times 5. Multiply each one of them by 2. F prime of 4 equals 5 minus 8 over 20. Negative 3 over 20. That's the slope of the tangent line. Did anyone catch a mistake? No one caught a mistake? No one caught the mistake, guys? There's a mistake somewhere. Okay, let me show you the mistake. There's a 2 here. It's a missing 2. So that's gonna be 25. And this will become 100. It's 100. So now, if I want to finish the problem, y minus y1 was 2 over 5. We found it. The slope, we just found it, negative 3 over 100. X minus 4. You may multiply negative 3 over 100 in plus 3 over 25. Then add 2 over 5 in. 3 over 25, add 2 over 5, multiply by 5 by 5. That will give us negative 3 over 100x plus 13 over 25. That's the answer for the tangent line. Now we need to find the equation of the normal line. Equation of the normal line. Okay, so that's the first one. Part B of this, we need to find the equation of the normal line. Remember I said the tangent line and normal line are perpendicular to each other. So they have opposite reciprocal slopes. So the slope of the normal line, it's negative reciprocal. So you flip it and make it 100 over 3. The equation becomes 2/5 100 over 3 x minus 4, like that. And now try to multiply it out. Let's finish it now. So here we keep this part the same. This is 100 over 3x minus 400 over 3. Add to both sides 2/5 minus 400 over 3. Multiply by 3 by 3 by 5 by 5. 100 over 3x, 6 over 15 minus 2000 over 15. Y equals 100 over 3x minus 1994 over 15. Any questions about this?